This is chapter 23, Inferences about Means. And what we need to understand here is that we're going to be using a whole different distribution. We're going to be using the t-distribution designed by William Gossett. So the t-distribution is just like a normal. You can see the dotted lines here on top, and the t is the one that's smashed down a little bit by Mr. T's fist. He says, "I'll pay the fool," and smashes it down. So it's symmetric, it's just like the normal. And as it gets more degrees of freedom, it rises back up. And it's really just like the normal after about 40 or 50 degrees of freedom. It's very, very similar. We're going to, for this chapter, run tests and make confidence intervals. I'm going to go through the mechanics on those and kind of look at some output and show you how to read it and show you how to understand it. So we need to make sure we have the assumptions. The assumptions to start out are the independence randomization condition and the 10% condition. Those are the first two assumptions. Next, we will need a nearly normal distribution. And what does this mean? It means for really small sample sizes, we need it to be really normal. But for larger sample sizes, such as 40 or 50, it could be skewed, it could be a little bit crazy. So the distribution of means from those larger sample sizes will be just fine, and this follows the central limit theorem. So let's go back and look at the equation here that we're going to use to create a confidence interval. The equation right here, once again, has at the center what we are using to estimate the true mean. We have the sample mean. Sample means make confidence intervals for the true mean. We also need to decide our confidence level. This confidence level is decided by the t-distribution with n-1 degrees of freedom. So right here is your distribution. Next, we have a standard error. The standard error is just this equation right here, s over the square root of n. So we're simply taking the standard deviation and dividing it by the square root of n. So we can see how to use this. If you go into your calculator right now, you can actually go to Stat, Test, and go down to t-interval. And this will allow you to enter in everything. You don't even need to find the t-star, it'll calculate that for you. You just need to enter in the mean and your standard deviation and your sample size and your confidence level, and it'll create the interval for you. Nice, quick, and easy. You don't even have to worry about finding the t, but you need to know that you're using the t distribution, so you'll click t-interval, which will be a little ways down. Try doing that now, and maybe try doing a homework problem with that if you haven't already. Next, we need to look at some of the tests. So when we scroll down here a little bit, we're going to get down to the test. Scroll down to a test. Here we are. Another confidence interval. Sorry, I paused right there for a moment. Here we are as the test. The test is going to take our sample mean and take some test mean right here, our null hypothesis for what the mean is equal to. Then we're going to divide it by the standard error. This will give us the test statistic. We are going to plot this on the t-distribution. Let's scroll down here a little bit, and they've run a test right here. As you can see, we could run this test ourselves. We can actually plot this on the distribution, and this is a very small p-value. We can look at the right-tailed test, which would be greater than this. The left-tailed test has a large p-value. Well, if we landed all the way up here with our test statistic, saying that our sample gave an average right here of 0.091, well, does that seem like it's less than 0.08? No, we wouldn't have evidence for that. That's why the large p-value wouldn't have us reject the null for the less than. We could reject for the does not equals or the greater than. Those are the three alternatives right here. Does not equal, greater than, and less than. Looking at this even more in depth, we can actually find the sample size, because the degrees of freedom is n-1. So the sample size for this test was 150. You can find this in your calculator under TTests. This will be one of the very first things to click. And you can go in there and actually input this data and get the same results. Try that right now. Go in and test 0.08 and then use an estimate, your sample of 0.09134 and a sample size of 150. Run all three tests, see if you can get the results. This is a good practice. Make up a problem in your head with a class that scores an 80 on a test, and we want to see if the true mean is less than 85. The standard deviation for their test was 8, and we took a sample of 20. Rewind the video and maybe get the numbers. See if you can input them and test to see if we have evidence that the true mean is less than the hypothesized mean. Give it a try, and this is this chapter in brief. Good luck.